Hello everyone, my name is Prithviraj. In this video, we will be taking up another example for ALP programming, that is computation of an equation. We will take one of the equation and see how we can solve it using ALP program. Let me take an example. Let this be an example, that is 6x square minus 9x plus 2. We should give the value of x and the program will compute the answer for this one. Let us write a program for this one. Now I will open Keil software. I'll create a new file over here and start writing the program. First, we will compute this one. In this, we will compute this one, x raised to 2 first, and then we will multiply it by 6, and then we will add 2 to it according to the Bottomless rule. In Bottomless rule, addition comes first. So we will add 2 to this answer, and then we will multiply x with 9 and then subtract this with whole answer. Here I will write move r3 comma hash x. Let this be x for a moment. I will change it afterwards. Now x has been taken in r3. Now we should do the square of it. Here you can see we should do the square of it. So we use mul instruction. The syntax of mul instruction you can see it over here. I will show you. There are two syntax of mul instruction. That is mul, this one, this is destination, this is source, and the other one is this one, mul condition yes, rd rm rs. You can put the condition over here, which I will deal in later part of the program, later part of the video series. This S about this I have told in the previous videos that it will affect the conditional flag. And this is the destination register. These two are the source register. These two will be multiplied and be stored in destination register. So I am now going to use this instruction over here, first one in my program, to square the x value. Mul r4 comma r3 comma r3. That is, now r4 has x square. This is the comment line. Now I multiply x square with 6. For that I will take 6 in one of the register, that is move r5 comma hash 6. That is in the equation this one 6, and then I multiply 6 with x square. I have taken 6 in one register. Now I will multiply 6 with x square and store it in r6 comma r5 comma r4. r4 is x square and r5 is 6. I have multiplied this and store it in r6. I will write it over here as a comment, r6 . Now the first part has been completed. We have got this one. Now we will find 9x and keep it in one more register. We will take 9 in one register. Let me take it in r7 comma hash 9. Then I will multiply 9 and x and store it in r8 comma r7 comma r3. X is in r3. Now r8 is holding 9x. Now we have got 6x square and 9x. Now we will add 2 to this one, because according to Bottomless, addition should be carried out first. So we will add 2 to this one and we will store it in one more register, add r10 comma r6 comma hash 2. I have taken this type of add instruction. In the instruction set you can see that it is valid, register and immediate value. This rotate immediate is same as that as move instruction. It has same limitation as move instruction. So now R10 has 6x square plus 2. We have added 6x square plus 2. Now we will subtract 9x from that one. We will keep the answer in R2. Sub R2 comma R10 comma R8. That is R10 minus R8, that is 9x, and store it in R2. Now R2 has the result of 6x square minus 9x plus 2. Now I will end the program. This is one of the syntax of subtract. I will show you the syntax of subtract in the manual. This is the syntax of subtract. This one is same as that of addition, that is subtract Rn with the immediate value. I have used the second type of instruction. The example for this instructions has been given just below it, like this one. How you can use the subtract instruction? What will happen? R0 comma this one. This is rotated once. R1 is rotated once and subtracted by R1 and stored in R0. So now we will save this one as expression exp.s. These are all the comments. Anything written after the colon are comments. Now we should change the x value with some real values. Let me give it as 2 and save it. We will analyze what will be the value of this one when x is 2. Its answer will be 8. Now we will see it over here. I am going to save it, compile it, 0 error, 0 warning, start the debug session. I have not added this one in the source loop. I have to delete this one first, and I am going to add the expression.s file. Add, close. Oh, it has not been added. I'll add it once again. Close. Compile, 0 error, 0 warning, start the debug session. Now 2 is transferred to R3 for the first instruction, and it is squared and stored in R4, that is 4 is stored in R4. Now 6 is taken in R5 and is multiplied with x square and is stored in R6. 6x square, that is 18, is stored in R6. Now 9 is taken in R7 and multiplied with x and is stored in R8, that is 12. Now this addition has been occurred, that is R6 plus 2. R6 value is 18 plus 2 has been done and is stored in R10. Now the subtraction occurs and the final result will be in R2. See, that is 8. The answer we have got here is same as that. I am going to stop the debug session. You cannot give the decimal values over here. There is another method for doing it, and the limitations of this program is that the final result should not exceed the limitations of the resistor, that is minus 2 raised to 31 to 2 raised to 32 minus 1. It should not exceed that. The final result should not exceed that, and also the intermediate values also should not exceed the limitations of resistor. The variations in the subtract instructions are, there are these many variations in the subtract instruction. We have used this one, or you can say this one, without the left shift operation. About this left shift I have told you in the previous video, and we will use some of this in the upcoming programs, and I will explain them there. If you don't understand what is this immediate 3 or immediate 8, immediate 7, it has been given in the first part of the manual. You can read there and you can try this on your own. Subtract and also the multiply instructions variation. So there are two variations in multiply instruction, that is 3 resistor and 2 resistor. You can do this on your own and practice it. So this is it for this video. See you in next video. Till then, take care. Bye.